In this video, we're going to take a look at some of the soft engineering methods that can be used to manage flooding in rivers. So the last video covered the hard engineering strategies. You may well remember from what we did then that those are methods that try to control, so that's what they do. The when, they were very common in the 20th century, but they're still used in some places today. We looked at some examples of where they're necessary, still to be used today. And where they use then, those are some of the places where, particularly in urban areas where the river is close to valuable land, to protect the land and the infrastructure. Here's one particular method, that's your flood walls. So a quick recap before we jump into soft engineering. Dams, they make the discharge more regular, so that's the good thing about them, but they can cause habitat loss in the reservoir and displace the locals. Next up was levees. What was the benefit of the levees? They increase the river capacity, but what was the downside? If they fail, then the flooding is a lot worse. What was the next method? Dams, levees, and flood walls. What are the benefits of flood walls? Well, they too increase the capacity and they protect the infrastructure around the river. What's the downside of them? Cost of maintenance, yes, of course, and that complete loss of habitat. They don't look at all natural and they don't create those natural habitats for plants and animals. Finally, you can straighten and deepen the river. Why does that work? What are the benefits of it? They increase the capacity of the river, yes, and increase the speed to get the water out of the way more quickly. What's the downside of it? Yeah, it can move the problem of flooding further downstream. You move it out of the way, it becomes somebody else's problem, but it's still a problem. And the rivers can silt up. The rivers will deposit, and you will need to come back and keep on doing this over and over and over again. So with hard engineering trying to control the natural processes, you can, to a degree, get flood control, but look at all of those negatives down underneath. So that's what then brings us to the soft engineering. This is trying to work with natural processes rather than trying to control them. It's definitely the preferred approach in the 20th century where we can use it, and there are various places, and we'll see them as we go through this. So for example here, upstream of an urban area, or in this particular photograph, an urban park, that kind of thing. The high value land is further away, and you're using, in this case, the method is Washlands. It's using the natural store of the floodplain to store the water there where it isn't going to damage anything, and not own the houses behind it. And the plants that live there are adapted to that. They grow in places that are periodically flooded, so you increase your habitat diversity. Right, let's jump in then and take a look at our soft engineering methods. The first one is the term washlands. This is the area of the river's floodplain left undeveloped where flooding is allowed to occur. Now, the main benefit of this is that it allows for this natural store of water in the drainage basin. This is where it is working with the natural processes. So you're not saying to the river, you must not flood. We are human beings. We are smart, intelligent creatures. We will tell you exactly what to do, and you will do it. Understood? And the river goes, yes. Let's just see how that works out for you. Instead, this is taking an approach that says, river, do you know the way that you like to flood? You know the way that's your thing. It's what everybody knows that you do. Oh, there's the river's going to flood. River, and you're flooding. It's so cute. Well, seeing as you're going to flood anyway, if it's not too much trouble, would you flood this area here rather than in where all the houses are? Because, like, if you flood this area, it's not going to damage the houses. And you know what? All those little plants are actually adapted to it. They want you to flood. They'll welcome the flood. And then all the little animals that live in all those little plants have their little homes protected. Is that okay? So working with those natural processes and creating that natural store in the drainage basin and creating those diverse habitats. So this is what you've got to add to the diagram in your notes. There is the upstream area to the left, and you're letting that flood. It's that natural store. The water is staying there. less water moves downstream, and there's a reduced risk of flooding then in the urban area. That's working with the natural processes. Alright, pause the video and add that into the diagram in your notes, please. Okay, it's recap time. Let's get this drilled into your head. Dams, do you remember the positive with dams? Makes discharge more regular, but what does it impact? Habitat loss in the reservoir and can displace locals. What was the next one? After dams we looked at levees, that's right. And what were the positives of levees? What do levees do to control flooding? Yeah, that's right, they increase the river capacity. They hold more water. Brilliant. As long as the water stays there, because what's the negative? If the levees fail, then the flooding is a lot worse. Right, okay, dams, levees. Next up was flood walls. Yes, so benefits of flood walls, how do they work to control flooding? Yeah, well, they increase capacity too. They do protect the infrastructure, the buildings, the other roads, electricity supplies, things like that. Oh, but there's the cost of maintenance, yeah, because they do get damaged, and there's the loss of habitat, yeah, because they're not natural environments. Okay. Last method, straightening and deepening the channel. Yeah, how does that help with flooding? Oh yes, it makes the river able to hold more. Yes, if you deepen it, and it speeds out of the way more quickly, gets the floodwaters out of your area, but, yeah, that's right, moves the problem downstream. The rivers can silt up again. So that then brings us into our soft engineering, washlands. How do they work? There's a natural store of water, but the land can't be used for other purposes. Now, here's the thing. I want you to start to compare this negative with these negatives. And you can see that this is nowhere near as bad as this. So there may be some downsides to the soft engineering, but as we start to assemble this, you'll see that they are not in the same scale as the other ones. Okay, second soft engineering method is land use zoning. This is when planners decide what land uses may be allowed in an area depending on the likelihood of flooding. Now, if you look at this diagram here of a river with some buildings nearby, so it's a river going through a reasonably built up area. It's not that hard to figure out which part of that is going to flood most regularly. Which part's going to flood most or least regularly? So, no surprising then that the places where you have most flooding close to the river are the places where you put the less important or less impacted land uses, and the ones that have the higher value you put further away. So you can put pasture by the river. Doesn't really matter if the pasture gets flooded. Okay, maybe the farmer can't use the fields for a few days, but apart from that, there's no major impact. Then you can come up here to crops and sports pitches, less regularly flooded, but if they are flooded, they're not necessarily going to be causing major damage. And then the place where you have the greatest risk of flooding, that's where you place your highest value land uses. So, quick recap again. Dams, positive. Discharge more regular, negative. Habitat loss and reservoir and they displace locals. Next up after dams was levees. Positive with levees is they increase river capacity, but what happens whenever they burst? Flooding is worse. Next up was flood walls. Oh, they increase the capacity. What else do they do? Yep, they protect the infrastructure. Brilliant, but yeah, they're going to be maintained over the long term, and there's going to be loss of habitat. Next up, deepen and straighten the river. If you deepen it, you increase the capacity. If you straighten it, you make it faster, just like this recap, but that moves the problem further downstream. The rivers can silt up again. That brings us into washlands. The benefit of washlands, it is using the natural store of water in the drainage basin. The land can't be used for other purposes, not necessarily a major issue though. And land use zoning, the less vulnerable land use is closer to the river, so it's less impacted when it floods, and it may be difficult to relocate land uses away from risk in certain places, and therefore you'll have to come to hard engineering. Right, which brings us to the last method, which is afforestation. 2 F's in the spelling of that. Afforestation is a planting of trees. It normally occurs in the upper course of the river, and this is bringing us right back to what we did at the start. How might planting trees help reduce flooding? pause the video and have a little bit of a think. Remember that little section where the what happens if all the dominoes, this leads to this, leads to this. So what are all the dominoes that are going to be knocked down if we plant trees in the upper course of the river? Have a wee think. Okay, I wonder, is this what you were thinking? If you plant trees, there is more interception. If there's more interception, this slows the water down, so the peak of the discharge, the maximum amount of flood water in the river at any one time, is lower. That means that there's less flooding. So more interception slows the water down. Just chill out, water. Let's not be in a rush to get to the river. Let's take our time. The other thing is that it increases evapotranspiration, because as the water is just resting on the leaves there for a while, maybe the sun comes out and maybe it evaporates back off before it even reaches the ground and heads to the river. And of course the trees take up water via their roots, that's your transpiration, put them together, and as well as slowing down the flow. The interception, remember, is from our systems approach: input, output, stores, transfers. Input, output, stores, transfers. Which one is interception? Input, output, stores, transfers. Yeah, interception is a store. Yeah, so you're storing the water for a while. Evaporation, which one? Evapotranspiration, which is it? Input, output, store, transfer. Input, output, store, transfer, which is it? Yeah, it's your output. You're taking the water out, you're holding it back for a bit, and you're reducing the amount in the river itself and the drainage basin. So there you go. This is what's going on in our diagram. There's the upper course where you've got the trees planted, the forest intercepts it, and the evapotranspiration. Now, why the upper course? Well, it's largely because in these maybe upland areas near the source, up on tops of hills, you've got more room to plant large forests of trees. If you think around, especially if you come up into the likes of County Antrim and places like that, I don't know if you've ever driven up through County Antrim, in some of the upland areas there, you'll see trees and forests have been planted there, which can help with this process. Then that means that there is less water flowing downstream, because there's an output of water, evapotranspiration, and interception is a store. It slows everything down. So there's less water flowing down at any one time, and there, of course, flood risk is reduced. Okay, so you can add that into the diagram in your notes now, please. Okay, so that's the end of our looking at the different methods. I just want to finish off by making this point about looking at our flood management, not just as what you do in these little individual pockets or places along the river, but to see this as catchment scale or drainage basin wide approach to it. There will be places, for example, down here in the urban area, where you have no choice but to use hard engineering. And if you're going to use the hard engineering there because you've got the high value land nearby, then are there ways that you can soften it slightly? Can you set the flood walls back a little bit? Create just a little bit of space around the river, create habitat diversity there, allow for a little bit of the storage capacity of the floodplain in this area. Can you soften down those hard engineering bits a little bit here? Here's somewhere here where you have some buildings as well, where you've had to put the flood wall there to protect them, but the other side of the river here, where you've got the sports pitch, well, there's no flood wall there because, yeah, okay, it might make it a little bit soggy and waterlogged for a while, but it's not going to be the end of the world. You come further up here and you see some of the trees that are being planted, and you see some of this, what's called river restoration, where you're creating that habitat diversity back up here to the trees planted in this area. So where you can use soft engineering, where the river can be left in pretty much its natural form, we leave it in its natural form. Where there is little option, little choice, then perhaps we have to use the hard engineering. But even then, can we see them operating in a more natural way? Is that possible? Okay, here comes our final recap. So let's see if you can be ahead of me this time. Dams. What are the benefits of dams? discharge more regular, but what do they destroy? Two things: habitat loss, and they can displace the locals. Next up after dams was levees. What's the main way in which levees control floods? They increase the river's capacity. That's it. The downside though is if the levees fail, then the flooding is worse. Flood walls were next. As well as increasing capacity, what did they do? They protect infrastructure. That's right. What's the downside of it? The cost of maintenance, yes, and the loss of habitat. And the final one: dams, levees, flood walls, and deepen and straighten the river. If you deepen it, you're going to increase capacity again. If you straighten it, you make the water faster, increase the speed, moves it out of the way, but that moves the problem downstream and the rivers can silt up. So on the other side then you've got soft engineering. You've got your washlands. They use the natural store of the water. You can use the land for other purposes, but again, that's maybe not a huge problem. Land use zoning. The less vulnerable land uses are closer to the river. The more valuable, less or further away from the river. Downside: some more valuable land uses may not be able to be relocated, and therefore you might have to use some of the hard engineering strategies there. And finally, afforestation. What does it do? It increases interception, so it increases the natural store, and evapotranspiration, the natural output. But it may be difficult to find land for these trees to build them on, and the trees that are planted tend to not be deciduous. They tend to be coniferous trees because they grow faster. Get this right yet? Coniferous trees are not the natural trees that you would get growing in most areas in the UK. Deciduous trees would be the ones that would grow there, but they just take too long to grow, and they lose their leaves during the summer or the winter and make it less effective in interception. So there you go. There is your totality of it. Whenever you're revising and learning this, absolutely look at something like that. You can screen grab that, print that out, put it in your books. There is your summary. But the key thing then is when you use that summary, you then have to be able to unpack those, and you need to be able to give more detail on them, and use this for retrieval practice as a springboard into the detail. But there's your hard engineering tries and control, and there's your methods, and there's your soft engineering working with, and there's your methods.